Assalamualaikum and a very good morning to everyone. I am Diana from IK Academy. I would like to welcome all of you to our webinar of the Learn with IK Live series. For your information, this webinar is organized by our iClub by IK community page in Facebook. We have a dream to create and nurture a community of great engineers. So do join our community page and also don't forget to invite other people so that everyone can gain something beneficial from it. Just go to the page and click join. As a friendly reminder, please register yourself through Eventbrite to make sure that you won't miss any notifications for our upcoming events and as a record purposes that you have joined our webinar today. I would like to say thank you to all our returning audience and to those who are new and this is the first time that you heard about us. We are a technical training provider and we have the purpose of transforming engineers into greatness. At IK Academy, we wanted to build and inspire greater engineers for the world, integrating knowledge as a force for good. We believe that greater engineers, greater world. Neutrality is our priority. We are totally brand neutral with a strict focus on education. We are committed to provide the best learning experience to everyone. We believe learning is a lifelong process. Before we proceed with our webinar today, please like and share this live webinar with those who you think will be interested with our sharing. You may click the share button and share it directly to your social media page, or you may share around the link via WhatsApp, Telegram, or any medium that you may find. For your information, this webinar is streaming on our Facebook, LinkedIn, and also YouTube page. Please like and type hashtag IK Academy in comment to show your presence when you are visiting the page. So today we will have a webinar with the title of Solar PV Project Technology Selection. Our invited speaker, Mr. Channa Silva, will share his knowledge and experience with us. So before we proceed, let me read a bit about his profile. Yeah. So Mr. Channa Silva is an international consultant in solar PV with over 12 years of progressive experience in strategic planning, engineering, project development, training, and project management for solar and renewable energy technologies. He holds a Master of Engineering Science in Solar and Renewable Energy from the University of New South Wales, Australia, and Master of Engineering Management from the University of Technology in Sydney, Australia. He is also a certified expert in climate and renewable energy finance by the Frankfurt School of Management in Germany. As of date, he has provided his consultancy services for over 500 megawatts of projects worldwide in countries such as Sri Lanka, Australia, Fiji, Maldives, and Middle East. He has also worked with UNDP, UNICEF, UNIDO, and Asian Development Bank as a solar PV consultant. Further, Channa is a trainer under Solar Energy International Colorado, USA, and conducts training and workshops in solar PV technology. So, well, we are delightful to have Mr. Channa Silva all the way from Sri Lanka together with us today. So, Mr. Channa, you may switch on your camera and also unmute your mic. Hello, good
Hello.
morning.
Good morning, Diana.
Okay, good morning, Mr. Channa. So, how are you?
I'm good. Thank you so
You are
much.
good.
And thanks for
Yeah,
the introduction.
thank you. So, is there anything that you want to add up to your profile just in case I miss out any important any point that is important?
No, that's it. Thank you so much.
That's it. Okay, so to everyone here, please say hello to Mr. Channa by typing in comment section and don't also forget to type hashtag IK Academy. So I guess you guys ready for the webinar, right? Of course I am. Again, before we proceed with the webinar, I would appreciate your help to like and share this live show to everyone that you can think of. Or if you have any questions throughout the webinar, please feel free to type your question in comment section anytime and I will read your question accordingly after the presentation ends if time permits. So I think I will pass the presentation to Mr. Channa. Enjoy
Okay.
everyone. Okay.
Okay. Thank you, Diana. Thanks for the introduction and thanks for giving introduction about IK and what they do. So I'm going to take the slides forward from here. And today topic is technology selection under solar PV projects. Myself, Channa Silva. And before I start, I just want to give you an idea that technology selection is very broad subject topic in solar PV projects. So since that I'm restricted for 1 hour here in the webinar, I'm focusing on different scope of work for the webinar and also different subject selection for this particular webinar, and probably like missing parts and some of these case studies planning to take on upcoming training program on 16th and 17th under IK Academy under the topic of solar PV financing and risk management. So related to that, this particular webinar is going to taking forward. So today discussion points are giving you an overview about what is a PV module selection and importance, and inverter technology selection and mounting mechanism selections. So before that, I would like to quickly go through what exactly a journey of a solar PV project. So when it comes to a solar PV project, whether it's a residential or small scale or a medium scale or a large scale solar, every project has to go through a different stages. Like if I simply classify it into 4 categories, so it can be feasibility stage, and second stage can be permitting and planning stage, and third stage can be contracting in the sense of EPC or project management stage, where we call it as, start from brick to brick, start the installation. And fourth stage as the asset management and operations, it means operation and maintenance stage. And also if somebody really wanted that, you can have, fifth stage as the concept development stage, where that, investor or client think about to do a project where the concept is being developed and also being, start thinking of to. But in a real project, when it comes to a large scale solar, probably we can, comfortable of, dividing into these 4 categories. And I very quickly go through what exactly each stage is. Under the feasibility study stage, most of the cases, the client or the investor identifies the main uh, parameters which related to the project, like identify the sites, do the preliminary designs, and do kind of preliminary study on energy forecasting, simulation run, financial requirement, assessing what exactly your financial requirements are, assessing your regulatory requirements, and whether to go ahead with the project or not. And permitting and planning stage, probably it's getting the approvals, relevant approvals, and preparing relevant contract with different suppliers and the stakeholders. And the project management stage, as I said, like it start building from a brick to brick and start the installation from this particular stage. Probably like people think that this is the most important stage. Yes, of course, this is the most important stage when it comes to risk management, because the most of the issues happen during this stage. Probably we can say that close to 50% of the risk and damages can happen, because if you are not properly manage this particular stage of, project management or EPC. And finally it's operation and maintenance. Once the project is commissioned with the utility, so you can, start thinking on what exactly to be done and how you will have to have a proper well-named plan. So let's say if it is considering about the risk and everything has happened up to this point, and then only you will have to, take the project forward. If you have a proper plan, of course, you can again reduce some sort of risk. So this part is after the project commissioning, and it's throughout 20 or 25 years of, contract period, where that, client is engaged with the utility company. So under our topic is technology selection. Somebody can have a question that in which stage most suitable to going ahead with, technology selection. So then I'll straight away select here. So if you can select all the relevant technologies which associated with the project components, if you can select everything, plan everything well ahead at the feasibility stage, then definitely you can have, much risk reduced, risk mitigated plan, and also problem may encounter throughout the project will be much lesser. It doesn't say that even though if you plan well, there can be unexpected problems, issues when the project flows. And just want to say that to get a start, just to mark a stage, so technology selection is more suitable at the feasibility stage, where that, people start thinking on and also start doing preliminary study on. So let's quickly jump into module selection. Since that as I said, like I'm restricted with time, I just need to skip some of these points, like taking the flow. And is that technology selection means in a module selection, it only means the module type. So this particular graph shows that a famous a cell technology, cell efficiency graph since 1976, where the cell technology is being started up to current point of 2023. This popular graph published by NREL, National Renewable Energy Laboratory from US, and this particular graph consists of all the possible cell technologies and their relevant efficiencies already being achieved by different manufacturers, different research teams, different sources. So just want to show you that this is not the only criteria when you need to select a PV module. Let's say that this can be a useful tool where that, where is going to place the module that you're going to select. For example, let's say in blue color, you can see that the crystalline silicon cells, which is the most popular in the commercial world. And other than that, multi-junction cells, thin film cells, emerging PV, like organic and a different sort of inorganic cells technologies are there. Some of these, non-commercial PV cells and or rarely, available cells. Yes, of course, they have done their, efficiency achieved some more than 40% because of the commercial cost and, economics of scale. Crystalline silicons is most popular, and probably like for our installation, we use like probably 98% of the installation in global wide, we use crystalline based, and also silicon is abundant, is like available at very low cost. So that's also one of the reasons it's been popular. So in a nutshell, just want to say that simply the modules that we are going to use either in range of this area like 20 to 25%, probably reaching 25% at the moment because of the economics of scale of these crystalline silicon. That's also one of the reasons where the cost is lesser. So in a nutshell, just want to say that even though there are modules is being achieved much higher efficiencies, cell efficiencies and module efficiencies, we being used because of one of the main criteria, not only a cell efficiency, but also cost factor. Let's also think about what are the other factors that you need to think about when it comes to selection of a PV module. So I thought of, getting a module data sheet for that. So what are the parameters that you need to check when you are going to select? Mainly, I'm here going to talk for most of the non-engineering professionals, or those people, those who are going to involve with the procurement or the financing part. Probably engineers might know most of the information. So in the data sheet, we can, subcategorize as like the specification. The main category that I'm going to discuss here is the mechanical and general information, like dimension, area, thickness, weight, and the cell dimension. So why that is important? For example, is so let's say if you're focusing on a rooftop project or like a restricted land that you have and you have, project. So in that case, dimension, the cell efficiency is very important when you are going to select, because that help you to reduce the amount of an area that may required for, per kilowatt or per megawatt scale. So in that case, dimensions and the cell efficiency is being important. So in that case, so if you have a problem with that, of course, there can be a one selection criteria. So I'll quickly take a case study and quick exercise after these slides, and I'll show you how it will be the important. And the glass, yes, of course, glass thickness is one of these factors, and also backsheet. So when it comes to module manufacturers, of course, this they have like very high concern about backsheet, because when it comes to PV module, if there's a manufacturing defects can happen, then backsheet failure can be a major issue. So in that case, the materials being used for backsheet also one of the main criteria to be selected. And also one of the key things that I do have, since that I don't have much time, so I'm not going to dig into what exactly a backsheet and the material properties are, but that is one of the main things to be considered. and also encapsulate most of the cases. All the manufacturers use EVA, ethylene vinyl acetate, as the material, and also frame size probably is 35 millimeter or 40 millimeter. That is important because when it comes to a frame module, because end of the day, frame provide the mechanical strength to the PV module, and also nowadays that frameless glass modules are available. So when it comes to bifacial module, most of the cases we've seen frameless module, and also there's a framed module as well. So you can think on that these factors as well. So when you are going to select, and also connector specifically brand is important, because when it comes to, so you will have to connect one after the other, and also you will have to connect it with the inverter. So compatibility of connectors is very important. So in that case, brand of the connector always makes a price change. For let's say the particular investor wanted to request a price from the for a particular brand for the connector, so there can be a price change. So that it's important. And also junction box is a criteria to think about. And also the next category is the electrical data in the sense, probably like you can see that the IV curve here. Simply, I don't want to waste time. So here, so just a quick definition for the IV curve is like simply current voltage performance curve of a PV module. So every module which out from a manufacturing plant, it comes with a electrical characteristic, and it plot as a IV curve. So what's the importance of this IV curve? So when it comes to the operation, inverter recognize your DC system as one single or a differentiated IV curve. So this particular point as a maximum power point, where that every moment this can be changed, and define IV curve is for the standard test condition of cell temperature of 25 and irradiance of 1000 watt per square meter. In the realistic case, when it appear on the environment, because of these parameters being changed, the maximum power point, operating point can be changed. So this point will be the input to your inverter or maximum power point tracking. So I'm not going to define all these factors, just to have idea about what exactly the maximum power point tracking, and that particular voltage is maximum power point tracking voltage, maximum power point current. Views is maximum voltage, which can appear through both terminal and short circuit current, and when there's no resistance, that's the maximum possible current where that applicable. So based on these electrical parameters, I'm just wanna try to define few other parameters like power tolerance. So when it comes to power tolerance in the sense where that manufacturer compromise from the rated power that you are requesting. Earlier days it was like plus or minus 5% of the rated power. Nowadays, most of the cases we've seen that every manufacturer would be able to provide 0 to plus 5 watt power tolerance. In the case, let's say that if you're ordering 550 watt module loader, you might get like 20-30% of the module from 555, getting 5 watt extra. So that also key. So when it comes to a bigger project where that let's say that if you're ordering for 100 megawatt, what's the amount of extra 5 or 2 watts that you are getting? And also if you can sort that particular order in a way that having that 40% of your 500 watt in a one container, and the 505 and 502 in a different one, because you can connect the similar capacity of the current profile into the relevant string. There won't be a mismatch. In that case, you can have that additional power gain, additional 2 watt or 5 watt for that entire 100 megawatt order. So can you imagine that what would be the extra energy gain? It's not a small amount if you consider and simulate. For example, let's say it's a 50% of the plant. It means 50 megawatt is for 500 watt using, and another 50 megawatt from 505. It's when you have 5 watt extra edge. So you can use it for the simulation as well to check what exactly your power energy. Module efficiency is simply the cell efficiency and the area which always matters, the range of 22 to 25, and also that is not only the factor that you need to consider, and also it has to be in line with the cost of the module. Even though you are having the most efficient module, and also it can save some sort of land or roof area, but if it is so costly, so it is not applicable. End of the day, you will have to do the cost benefit analysis where your total project cost is pitched based on the energy yield, and that would be your cost benefit, and you can identify the return out of that. So temperature coefficient is one of the key factors. What is temperature coefficient? So when you are looking at a PV module, you can see that there are three temperature coefficient factors is being defined: temperature coefficient factor of power, temperature coefficient factor of voltage, temperature coefficient factor of current. What exactly it is? Simply that the temperature is sensitive with voltage and irradiance is sensitive with the current. And so when voltage is increased, when temperature is increased, voltage reduced from the rated given. So voltage starting point given is at the standard test condition of cell temperature of 25. So in this case, if we take this example, if the cell temperature go beyond cell temperature, which is the standard test condition of 25 degree, from each degree reduce 0.35% of the power. So let's say that in the operating condition of KL, let's assume that your ambient temperature around 35, cell temperature can reach 60 or 65 in that case. So there's a 40-degree difference from cell temperature standard and can reduce this much multiplied by 40. So can you imagine that? So like we know that because of the environmental factors and everything, there can be a power losses. But if we consider about the losses, if there's no additional shading impact, the majority of the stake, the major stake contains for the temperature loss. So in that case, if you can select a PV module where that their temperature coefficient is comparatively lower than the other, so then it will be a good selection in that case. Let's say that if you can save 2% or 3% energy loss reduction, so then it will be a, so in that case, when you are going to select a PV module, cost is one of the main factors, cell efficiency is one of the main factors, and also one of the key other factor is temperature coefficient. So let's say that if you have two 500 watt megawatt of panels to be compare, so you can straight away go and select, check what would be saved when it's during the summer days, or like especially a tropical country, because where the ambient temperature is so high. So this is some sort of comparison where that you can see how these monocrystalline, multicrystalline, and some other technology the cell temperature can save. I'm just not going to take this example, and few other factors also to be considered, like maximum system voltage, where that most of the cases we've seen that nowadays the commercial inverters is being used is rated for 1500 watt DC, and probably like if you're going to select PV module, we prefer to select 1500 watt rated system voltage, and also maximum fusing rate probably around 20 ampere to 25 ampere, design load, maximum wind speed, and also certifications and qualifications. Also one of the key things, so when it comes to the local regulatory, so that's so important. Workmanship and general warranties like 10-year or 12-year product warranties available from most of the panel manufacturer, module manufacturer, and 25-year or 30-year warranty. So that is a selection criteria, but probably the main point is majority of the manufacturers, top level manufacturers, manufactured under the same condition. So I've just highlighted few of the points and just want to give you an idea that how you going to select. So yes, of course, most of the cases we've seen that people tend to use with wattage capacity, or the cell or module efficiency based, or else based on the cost. But if you really wanted to dig with all these factors, so you can use kind of multi-criterion decision-making model, where that you can consider and compare similar capacity of three different brands. I'm just use few brands here, not to promote or not to demote any of these brands, just to take the example and show. And also based on your preference, these can be categorized. So simply based on the specification given here, the main criteria that I select is technology. Technology, under technology, I subcategorize it as cell structure, bus bar configuration, electrical characteristics. In this case, like temperature coefficient is under electrical characteristic. So where that you can put more weight on that, and the mechanical characteristic, certification, environmental concerns, customer satisfaction, even cost. For example, you can compare these technical ones with 60% weightage with the cost of 40% weightage. Likewise, under the preference of yours, you can select this kind of multi-criteria to select PV modules. For example, in this case, I've put 28% for the technology, electrical 25, and customer satisfaction, again, I said like 25%. So that's so important. So that would be differentiate from market to market from different brands. One brand in Malaysia probably like leading, that particular brand in another market may be poor because of the staff. So that has to be, so these has to be, customized. So once you do that, so you can, give a list on the, based on the specification, and give some ratings. And the collected ratings would be, the taking the total of these, weighted rating can be a selection criteria. And also I'm looking forward to take a good, the cost level, cost benefit case study, not here in the training program as well, just to want to give you an idea. And so how you need to, consider the cost versus the balance of system. So when you are going to select a PV module. And also just to give you an overview, I just want to show one slides have been taken from, the slide been taken from the web. So showing some sort of, efficiency based selection a table, and similar tables are available based on the shipping volume and company stability. Again, want to say that, and also the Bloomberg New Energy Finance also, and PV Tech, different independent research studies also shown different list. That also can be used when you are going to select PV modules, because but that would not be the only criteria. That's my point is, like, for example, let's say somebody is with highest financial stability, someone rank as 2 or 3rd or like 5th or 10th, maybe having much some other way of superior products. So that's why I said, like, you will have to go with like different cost, cell type, and the technicalities. So when you are going to select, not only going with the brand, of course brand reflects a lot of stuff, and also good brands or produce a very good products where that being used. I've used like all of these brands, to be honest with you, but each cases. So when it comes to different situation, selection would be different. That's why you just want to give you an eye opening for this from a different angles. So the next one that I'm going to take is the inverter technology. So I'll very quickly go through this one. So what I'm not going to waste time here. What exactly role of the inverter? Simply everybody knows that inverter does is convert DC power to the alternating current, alternative power, with controls, with the quality output, and to be delivered to grid. So we are here to discuss about the grid connected inverter. So in that case, your interface would be grid. So there are different sort of regulation is being defined by regulator every day. So in that case, your inverter has to comply all of these standards and also has to do this job properly. So in that case, even though the cost of the inverter from the total cost probably around 8% of the cost, but in role of the inverter is like have a more stake because that's kind of brain of the system. So in that case, there are a few things to be considered. The maximum power point tracking, simply maximum power point tracking is the feature where that, inverter identifies where the maximum power point of the from the DC side. As I mentioned that from IV curve, maximum power point for each given moment with the environmental conditions, different condition every moment, that maximum power point is being keep change, it's been changed, and with that changes, that maximum power point for that particular instant will be the input to the inverter. So there are different, functionalities with the inverters. I'm not going to take all of these technical stuff. Just want to highlight that what are the technologies of inverters available for grid connected products. So first category that I'm going to take is the central inverters. Central inverters simply being used for large scale solar and probably the range of like 500 kilowatts to 3 megawatt up to. It means that, let's say that your inverter capacity is like 2 megawatt. It means that that particular inverter can connect with 2 megawatt or plus size of DC circuit of panels into one single inverter. So each inverter types does have its own pros and cons. For example, let's say if you're considering central inverters, there can be, so bulky, it's hard to handle. And also, if there's a failure in the inverter, you will lose that particular 2 megawatt of, energy generation. That can be disadvantage. But when it comes to advantages, probably like cost will be half compared to swing and other inverter types. And also same time, the transformer and the main AC combiner panels all are integrated with, container size solutions like 20-foot or 40-foot container size. The bigger applications, it's depending on the application size. So those are kind of advantages. So that's why this particular technology is being mature since last 2 decades and people being used for a lot of applications. So, and the next category that I want to highlight is most popular category is the string type inverter, where that you can see from 1 kilowatt to probably the biggest string inverter available, as I know, it's 250 kilowatt inverter. So, so only difference is you are having maximum number of maximum power point tracking integrated with string type inverters. So let's say that if you have 100 kilowatt with 10 number of maximum power point tracking, what does exactly it mean is your inverter can cater 10 different separate DC system inputs to get the maximum power point output. If you're compared it with the central inverter, you'll have only one MPPT output most of the cases, like entire 2 megawatt can see as one single maximum power point, one single IV curve that can compromise a lot of energy wastage. Let's say that if some modules isn't working or any other shading impact or any other environmental condition, that may help to reduce lots of energy. So that's energy loss is being reduced using this technique. And also just want to highlight that this is very robust and mature technology, cheap compared to modular power electronics, but quite expensive compared to central inverters. But the only difference is, let's say that somebody is having a rooftop pair that, having, multiple planes to install, roof plane to install, then it can be, string inverter would be advantageous having, connected with different MPPTs. So there are two other modular power electronics categories, like optimized string inverters, like where that, you can use power optimizers to each of the module, and optimizers are connected with the one string inverter. And the next category is the micro inverters, where that, each module can cater with micro inverters. So your module is giving straight away AC power output. Most of the cases we've seen that rooftop application is being used for these MLPEs, and also same time just want to highlight that some of the rare cases also see ground mounted project also being used these MLPs, especially in US. It's so popular. They have actually a rule for a rooftop and rapid shutdown. Because of that rule, and under NEC 690, they have, if it is a roof mounted project, you will have to have a rapid shutdown facility. Then that can be catered from optimizers and also microinverter technology. The only main disadvantage is cost. Your inverter cost budget would double compared to the string inverters, and also when it comes to maintenance, if there's a failure, so you will have to reach module by module to replace the optimizers of microinverter. But when it comes to, if you're comparing advantages, then the thing that you can taking advantage is like the much deeper level transparency compared to central inverter. For example, let's say central inverter, you have to see your entire 2 megawatt block as one single output through your inverter. But let's say that if you have 2 megawatt with microinverters or optimized technology, then you can have output from each single module, and also that particular 2 megawatt block giving a module level maximum power point tracking, and each of module gives maximum power output because it tracks module level. So when it comes to maximum power point tracking, so each technology does have pros and cons, as I said. And so how to select one over the other comparing the capacity? That's what I said. Like, of course, you will have to work on the cost and also benefit that you are giving. For example, let's say that you are going to simulate through a PV or helioscope, any other similar software. So you will have to be control over some parameters when you are going to do simulation comparing different technologies. Especially the main factor is the mismatch, module mismatch and the string mismatch. By using that, considering the output, you can just check the saving out of that. And also if your investor is willing to spend more money on that, more transparency, I think it's a good one to install. And when it comes to large scale solar, nowadays string inverters are popular because it's at a medium scale when it comes to cost, and also giving lots and lots of advantage. So I'm not going to take all these specification one by one, but just want to highlight that. So when you are to select a technology, we are among 3 different types: central, string, and module level power electronics. Mainly, you will have to do a cost benefit analysis to identify what exactly the cost of inverter, not only the cost, but also balance of system, where that, how you save cables. For example, let's say when it comes to central inverter, all the DC inputs goes to the central inverters through combiner boxes and all. So micro inverters, probably AC output. So you'll have to have a much AC cable budget than DC cable budget in that case. And string inverter, how to place inverters in the not only place all the inverters in a one single room and take all the cables all the way to that particular room will increase the budget. So there are many things that you need consider. And also when it comes to selection of right inverters, of course you will have to, again, as I said, like project capacity, performance, MPPT voltage range, and module technology also being related, and also the regulations, the power quality compliance issue, reliability, and how you do the maintenance, and how you should address for the mismatch. Shading condition, in the sense that let's say that if you have like multiple phase roof, where that one phase is facing a half shading, and probably if you can select maximum, you have multiple maximum number of MPPTs with that inverter, so then you can reduce the amount of energy is being lost. So as I said, it's fully case by case situation, where that you'll have face considering every factor: cost, and your benefit would be every time here is the energy yield. So how you overcome that problem, and that help you to select a good product. First, size of the inverter, then you can go for a brand using a different sort of selection criteria, like especially with the reliability and service reliability is important, because when it comes to failures of projects, most of the cases we've seen that uh, it can happen through inverter. So you'll have to have a proper supporting team from your local or regional support from the inverter suppliers. So in that case, selection of that is a critical job. So there are a few other factors like AC output and also different sort of list which related to inverter. I've quickly explained through a data sheet. So I've considered here 250 watt, 250 kilowatt of inverter. Here the DC input range is 1500 watt, and the working MPPT range is 500 and 100 1500 range. So in that case, you can, have a string where that your minimum voltage for temperature corrected shouldn't go below 500, and temperature corrected maximum voltage shouldn't go beyond 1500 to have a proper smooth operation. And apart from that, in this case, you can see that the maximum number of MPPTs are 12. So in that case, you can have your 250 plus DC circuit categorized into separate into 12 circuits and could get connected here. And each circuit can have two as inputs. So likewise, in this case, you can see that AC voltage is 680 and 880. So it's rated for 800 volt, I guess. Yes. So you can see that it's odd voltage. This particular inverter doesn't suit to fit our utility, because our utility case of like 400, 450 in range, three-phase line-to-line voltage. So these are specifically designed for large-scale solar, where that it should integrate it with a transformer. This has this voltage range as the primary side. Probably your secondary side can be 33, or whatever the medium voltage or the high voltage, probably 132 or 220 or 500 watt kV, which required when it comes to connection. I think large scale has to be connected for transmission voltage level. So in that case, probably this will be an input when you're going to select, because there are cases where that, people tend to, so it always matters what's the voltage required, that, what is the grid interface that you are going to connect, whether it's a medium voltage or the transmission voltage or the a regular distribution voltage. So based on that, you will have to select your inverter product. So a few standards is being defined. I'm not going to take much, and you will have to, comply all the relevant the local standards. And there's a study shows that how, a DC to DC optimizer and DC to microinverter and string MPPT can save some sort of, energy loss if there's a panel shading. For example, let's say in this case, we've seen that 15% of shading appear for that. But if you can, separate and take module level maximum power point tracking, yes, of course, that can reduce for some degree. And also if there's, per string MPPT operation, also it's helped to save some sort of amount. And if there's no such, then there will be, no shading loss being recovered. That's what I'm trying to explain. And also when it comes to inverter selection, DC to AC ratio or oversizing factor is very important. Couple of months ago, I've done a webinar. I think you can go to IK Academy YouTube channel and find out. I've done a complete webinar on oversizing factor of a PVA system. So you can have more information from that. I'm just want to highlight that nowadays, investors wanted plant to be oversized by 40% or 50%. So your inverter has to, cater that much. So that also one of the selection criteria. So when you're oversizing, you will have to think about the amount of energy being lost from the power clipping. So this power clipping, what would be, how to do a cost benefit and how your cost benefit is benefit on that. So these are the factors always to be considered when it comes to, selection of inverter. So these points, probably few case studies I'm going to, take during the training program, which is going to happen in 16th and 17th and IK. So you can have more details about the training program from the team. So since that I'm restricted with the time, just want to highlight that oversizing factor also one of the key things to be again, and also same time cost benefit has to be integrated and also part of that oversizing factor. So the next one is mounting mechanism. How mounting mechanism works. So when it comes to a large scale solar, mounting can be have like using tracker or the fixed tilt. Tracker can be categorized into two categories: single axis tracker or dual axis tracker. Dual axis tracker in the sense it tracks the sun paths as well, and single axis only tracks the daytime, morning to evening sun paths only. So what would be the advantage over using a tracker is like, let's say that this red color thing is your usual generation curve for a fixed tilt. And if you use tracker, single axis or dual axis tracker, it widen your energy generation during morning and evening. So you can have much fatter PV yield curve, PV, generating power curve. So what would be the disadvantage then if you use tracker? The main is the cost, and it will impact on the project IRR, and also tracker does have moving parts, motors, and everything, and you will have to replace and maintain throughout. So in that case, that can be a hassle if you don't have expertise to handle that. For example, let's say trackers. Some cases you've seen that most at least one tracker each day can go to the store mode, so can lose energy than if it is installed in fixed tilt mode. So that's one of the key things to be considered. And so when it comes to ground mounted, it should be usual and can be different uh, different applications being there and more. But apart from our case, like benefit simulation and all, so that can be based on the latitude and also the optimum tilt angle, where that based on the location. And if it is roof mounted, again, it can be integrated or the partially integrated or unintegrated. It being like installed on the external surface, and based on the application, let's say that if you have a concrete slab to install, you can have the optimum angle. So that can be, high energy compared to the high steep roof. Likewise, let's say that based on the mounting method, your benefit can be changed. So your benefit, the project benefit can clearly reflect through project IRR, because the tariff is fixed. If you can reduce the cost, then it helps to improve the project efficiency, the financial efficiency. That matters for the finances. So in that case, during the project feasibility study, whether it's a module or an inverter or mainly mounting structure, cost and the technology may impact on the total project cost, and changing these parameters can cause and can gain much more beneficial than a standardized or the traditional system. So that additional gain 5% or 10% can lead for a better project, a better IRR, or better financial feasibility. So that's important for the investors, that's important for the financiers, where that they have to closely work on. It's not about like complicated engineering design. It's about what would be the optimum efficient or optimum financial efficient project to be built. So with IK, I'm going to take solar PV financing and risk management training program on 16th and 17th. Probably you can join if somebody is interesting and see it is as interesting and around KL. Uh, and looking forward to use these kind of concepts into case studies and the practical aspects in different forms. So, I'm going to close the the slide session right now, and I'm going to open it for a QA because since that we have another 8-9 minutes left, and if you have any questions, you are welcome. And Diana, and it's your time now, and you can come
Thank you.
and
Thank you,
join.
Mr. Channa, for the sharing. I think your training day is 17 and 18, not 16 and 17. The financing one, that one.
Okay, 17th and
Right,
18th. Sorry
17 and
about that.
18 also.
Okay, I missed
Okay.
that. Sorry.
Yeah. So thank you, Mr. Channa, for the sharing, and we hope that all of you learned something just now. So to everyone here, if you have any question to ask, just type your question in comment. And as for the rest of you, if you don't have any question, just type hashtag IK Academy, or probably you can type hashtag Greater Engineers, Greater World. So I think let's continue with the question. I will proceed with those that we gather from Eventbrite. Okay, so this one participant technical personnel. So he's asking about fire protection for rooftop solar system. Yeah.
Sorry.
He's asking about fire protection for rooftop solar system.
Okay. So basically, one second. 1 second. Sorry about that.
Mhm.
Okay. So fire protection, you can have in a different form. Like in US, as per the NEC standards, they use power optimizer technology for as a part of fire protection because it has rapid shutdown facility and your DC voltage goes below 50 volt entire DC string that can be used. And but if you are using string inverter technologies, one of the main thing that you need to consider is a check of all the connection points. That is so important because there's a loose connection in DC side, then cause a fire. And also during your maintenance, if you can have thermography, thermal images being can be taken, especially in the DC circuit, also can identify high resistance points. So that also can prevent a sort of fire. So as a before installation under the technology selection, of course, you can have a power optimizer technology where that if inverter is switched off on the grid is switched off, it shut down from the optimizer level, and that resist cause for a fire, and so rapid shutdown. That's why it's being used under NEC, National Electric Code in US, under code of 690. As I
Mhm.
remember, you can go through that if you want more information.
Okay, thank you. I hope Mr. Chana answer your question. Okay, so I guess we go to the next one is which stage is most suitable to do technology selection and when to do it?
Uh, so as I said, so we can categorize our project as 4 steps or 5 steps. So yeah, I prefer always, with my experience, to do a technology selection at the feasibility stage before start the installation for sure, to remove, to avoid all the hassles. So once
Mhm.
you establish with the technology, brands can be changed, doesn't
Okay.
matter, but fix with the technology where that you are going to install.
Mhm.
So as per my understanding, like every component, every tiny thing is important, like even the nut and bolt or the structure and everything. So that case, pre-plan prior to the EPC stage or the project management stage is very important. So in that case, plan everything at the feasibility stage. That's the most important stage where that you can reduce the risk. Probably some of these points can be discussed during the training program as well, how to reduce and how to mitigate the training risk,
Mhm.
how to select the stuff during feasibility stage.
Okay, I understand. Thank you. So the planning stage is most important, right? Okay. So the next one, can you give a brief step to select one technology to another when it comes to technology selection.
Sorry, I didn't get that. Sorry.
Okay, brief steps to select one technology to another when it comes to technology selection.
Okay. So as I explained, through module selection or the inverter selection or the mounting structure selection, of course, let's say that if you are going to take modules as one. So you will have to take the consideration of technical parameters which relevant to your case and also the cost parameters. And based on that case, you can change the other balance of systems as well and prepare a cost. And also you can find out the benefit through simulation, run energy forecasting, and find out your project IRR or other financial indicator that you're planning to take. Likewise, define different cases, and based on that, you can identify what would be the best financial option to go ahead with. Whether it can be a like a bifacial module with a tracker, or the monofacial module with central inverter, or the string inverter, or the modular power electronics. Likewise, define different cases and to a cost and to a benefit, and based on the financial parameters that going to achieve project IRR, plot it and find the optimum point based on that. That's how I do with all my experience that I'm, when it comes to a new project, new different case, which I'm going to face, select based on that. So that's what I said, like, I'm not going to market it again and again. Some of these case studies to be discussed in the training program, since that I'm restricted with the time, not able to discuss most of the stuff. That's why I explained the concept in the webinar and taking some of these examples into the training program.
Okay, I understand. So my next one is which inverter and module is best for the large scale solar?
Okay, I must tell you that most of these commercially available products are very good. And as I said, like, it's commercially available stuff. Again, most of the stuff are matured products, and it's again depend on the situation.
Yeah.
So probably one project, this technology can be suitable with the limited roof space or the limited landscape space, and another place a different type can be beneficial. But most importantly, when it comes to inverters, services and reliability is very important, because when it comes to a problem, you will have to find a technical team from the supplier, OEM, if you don't have such expertism inside your team, or if you don't have such a EPC team to consult. So in such a case, it's a fully case by case handling situation. Each case has a different way of, that's what I said, like some case with some perspective of the inverter, that can be bifacial technology with single access tracker with string inverter can be more beneficial than some other technology. So likewise, you'll have to have your own Excel sheet, own cash flow to get the best among all these products.
Yeah. Okay, so I think we still have 1 more minute. It comes to our last question, I believe so. So what's the role of maximum number of MPPT in an inverter?
Yeah, that's very important for me. Even though you install in a same plane of same angle if you're using, so you can think about that uniformity. We can use one MPPT inverter, but the difference is each each aging in a different way. So after 5 years down the line, 10 years down the line, there can be a string mismatch, and that mismatch can be sometimes 5% or 10% higher. So in such a case, if you can justify it through at the beginning, you can use multiple MPPT technologies. That's why most of the cases we've seen that the large scale solar is tend to use multiple MPPT inverters. So that's one of the reasons. And also that can be, environmental factors also can be changed. For example, let's say cloud movements. Half of the array goes with a cloud shading, partial shading, and also half of the array is doesn't. So if you are install it with with a multiple MPPT inverter, then you can have the higher energy. So these things at the beginning, when you're doing a simulation, you cannot, justify it, or like if you are not intentionally change those parameters. That's what I said, like especially the module mismatch and the string mismatch, you will have to add by your own, not using the default value. With your experience, how may it may impact, and also you will able to justify it to your client as well. So in that case, probably I prefer to go with multiple MPPT inverters.
Multiple PPT. Okay. Thank you, Mr. Channa, with all your answer and explanation and also your presentation just now. So I guess we have come to the end of our session today. So do you have any last advice or any messages that you wanted to tell the audience?
Just quick one, as I said, like, just summarize what I've said, like
Yeah.
always, even though you're coming from engineering background or like non-engineering background, like procurement or finance. So when you are into selection, risk mitigation was one of the key factors to be considered. Like I said, module failures to installation failure to O&M failures, all these. So that part you have to add to your financing, Excel sheet, how you mitigate that risk. So that's one of the key things under technology selection. We haven't discussed much in this webinar.
Yeah.
So you will have to see entire as a one single operation from feasibility study to 20th year operation, because end of the day, it doesn't mean that after the grid connection, okay, I'm done the job. It's not. After that, the real work start and you will have to do the maintenance. What are the unexpected risk, unexpected situations going to face? Consider this as a whole picture and put all the parameters into Excel sheet and get the best and optimal IRR based on all the factors. And probably I'm like to, discuss some of these important points in the upcoming training program, and looking forward to see you, at least some of you. And thank you, IK Academy. Thank you, Diana. Thank you,
Yeah.
Kelvin, to organize this. Thank you so much.
Okay, thank you, Mr. Channa, for your sharing today. I believe all of us here have gained lots of knowledge from you. So, like he mentioned just now, if you are interested to learn more from Mr. Channa, we have a scheduled session of physical training about solar PV project financing and risk management of this coming 17 and 18 October 23, and also another session on large-scale solar PV project development for engineers on 19 and 20th of October 2023. So please type in comments if you are interested, get more details about this training. So thanks again, Mr. Channa, and to all of you here, please leave some comments or feedback in Facebook, LinkedIn, and also YouTube about this session. And also don't forget to type hashtag IK Academy. Please like and follow our page in Facebook, LinkedIn, Instagram, subscribe to our YouTube channel, and also join our FB community page, iCarpla IK, to get latest news for our upcoming IK live webinar series and also other content sharing. Well, I hope I can see you again. Thanks from me, Diana from IK Academy. Bye-bye, everyone. Bye, Mr. Jana. See you.
Bye. See you.
Bye-bye.